Hello students, today we'll discuss about extrusion process. The topic covers a manufacturing process fourth semester. First of all, discuss about the introduction of the extrusion. It is a manufacturing process in which a block of metal enclosed in a container is forced to flow through the opening of a die. The metal is subjected to plastic deformation and it undergoes reduction and elongation of the material. Basically, it is an adaptation of open die forging method. We can see here in extrusion process in a cylinder you have a blade and the blade pushed by ram apply an external force on the ram and that is push it and end of the this block and mounted a die which is required shape of the material and the ram push inward and material extruded from the die and in a desired shape. That is basic phenomena of the extrusion process. The use of the extrusion in the manufacture of solid and hollow sections from non-ferrous metals and alloys. Sliding doors, tubing having various cross sections, door and windows frames, etc. These are the basic applications of the extrusion. Now the classification of extrusion process. Extrusion classification is based on by direction, by operating temperature, and by equipment. These are basic three kinds of extrusions, and in sub classification of extrusion here, the by direction, the direct forward or indirect backward, and by operating temperature, hot and cold, and by equipment, horizontal or vertical. That is basic classification of extrusion process. And the first one, classification by direction. And the direction, direct extrusion, according to classification by direction. It is a process in which the metal billet placed in a container is forced by a ram to pass through the die, like shown in the figure. In direct extrusion, that is the blade and that is ram and that's extruded product from the die and that is container. In this type, the direction of flow of metal is in same as that of movement of ram, as per shown in figure. The punch closely fits the die cavity to prevent backward flow of the material. That is direct extrusion process. Indirect extrusion process. It is a process in which a hollow ram containing the die is forced into the container containing metal, and hollow ram limits the applied load and the moment of metal is opposite to the direction of the ram as shown in the figure. In indirect extrusion, uh, that is ram, the apply on the axial force on the billet inside the container and extruded product is run out opposite direction of the force direction. That is basic phenomena of the indirect extrusion process. Classification by operating temperatures of the extrusion and the hot extrusion. It is done at fairly high temperatures, approximately 50 to 75% of the melting point of the metal. Die life and components are affected due to the high temperatures and pressures, which makes lubrication necessary. Pressure range basically 35 to 700 megapascal is the minimum. The types of hot extrusions is here. Basic three types and are lubricated, non-lubricated, and hydrostatic as per the shown in the figure. Lubricated hot extrusion. Before the billet is inserted into the hot extrusion container, a suitable lubricating system is positioned immediately ahead of the die in order to reduce frictional stresses. In lubricating hot extrusion, oil and graphite are used at lower temperature, where at higher temperatures glass powder is used. Copper alloy, titanium alloys, alloy steel, stainless steel, and tool steels are extruded using lubrication. Non-lubricated hot extrusion. No lubrication is used on the billet, container, or die for reducing frictional area stresses. It has the ability to produce very complex sections with excellent surface finishes and low dimensional tolerances. Solid and hollow dies with flat shear faces are typically used for non-lubricated hot extrusion process. And we can see in the figure that is RAM, and here is billet, and the shear surface is inside the container, and dead metal zone. Here a corner have a dead metal zone. That's a basic drawing of the non-lubricated hot extrusion. Hydrostatic extrusion. In the hydrostatic extrusion process, the billet is completely surrounded by a pressurized liquid except where the billet contacts the die. The rate with which the billet moves when pressing in the direction of the die is thus not equal to the ram speed, but is proportional to the displaced hydrostatic medium volume. The process must be carried out in a sealed cylinder to contain the hydrostatic medium. The pressure will be hydrostatic extrusion in the 1400 megapascal approximately. Advantages of this process is elimination of large friction force between the billet and the container wall. Possible to use dies with a very low semi-cone angle, approximately 200. This process can be done hot, warm, or cold. However, the temperature is limited by the stability of the fluid used. Limitation of this process is not suitable for the hot working due to the pressurized liquid. A practical limit on fluid pressure is around 1.7 gigapascal currently exists because of the strength of the container. The liquid should not solidify at high pressure. This limits the obtainable applications of this process: the cladding of metals and making wires of less ductile materials, and nuclear reactor fuel rods. The application of the hydrostatic extrusion process. Advantages of the hot extrusion is here is complex solid or hollow shapes can be produced by hot extrusion. Small quantities can be economically produced by the hot extrusion, and delivery time are often far shorter than alternative process in a hot extrusion. Limitations of hot extrusions is high equipment setup and maintenance cost. An extrusion process for metal is at very high temperatures. Dies preheated to increase its life, so there are chances of oxidation of hot billet. Process wastage is higher as compared to rolling. Non-homogeneous, that is major disadvantage or limitation of hot extrusion. Classification by operating temperature. The first one, cold extrusion. Cold extrusion is the process done at room temperature or slightly elevated temperatures. This process can be used for materials that can withstand the stresses created by extrusion. Advantage of the cold extrusion are the improved mechanical properties by the cold extrusion, good control of dimensional tolerances, and the improved surface finish, no need for heating billet, and no oxidation takes place in a cold extrusion. Disadvantage of the cold extrusion is the tooling cost is high, therefore large production lot size is required. Special coating is required to reduce friction and to maintain a lubricant film throughout in during of the cold extrusion. Limited deformation can be obtained in cold extrusion process. Applications of cold extrusions here: copper, lead, stan, aluminum, alloys, titanium, monoblatinum, vanadium, steel, zirconium parts can be extruded. Tubes, gear blanks, aluminum cans, cylinders, fire extinguishers, cases, shock absorber cylinders, and automotive pistons are manufactured by the cold extrusion process. The impact extrusion. Impact extrusion is a manufacturing process in which a small shot of solid material is placed in the die and impacted by a ram, which causes cold flow in the material. It may be either direct or indirect extrusion, and it is usually performed on a high-speed mechanical process shown as per the figure. Application of the impact extrusion is, although the process is generally performed cold, considerable heating results from the high-speed deformation. A short length of hollow shafts such as collapsible toothpaste tubes or spray cans, etc., require soft materials such as aluminum, lead, copper, and stainless steel in this process. Thank you.